when looking at this, we did the spring activity, and we realized if the wavelength got shorter, then the number of waves, I think it went from like 11 to 22 or 23 to 30 something. And so it was a lot quicker, and they had to put more energy into it, right? To get 30 or 3 waves, they had to put more energy into it. So that makes sense that the higher frequency you have, the more energy that the wave will have. Okay, now I don't have energy up here, but we will here in a second. So C is speed. Every wave, phone waves, radio waves, visible light, UV, infrared, all of those, they travel at a rate of 3 times 10 to the 8 meters per second. So 300,000 kilometers per second, if you were looking at another way to look at it. The lambda is wavelength, and it's measured in meters. It has to be meters. You can't plug in any other unit with a prefix in front of it for wavelength. It has to be meters. Frequency, this is Hz. It's not H2. It looks like it's H2. It's not H2. You guys have heard of hertz, right? Megahertz, gigahertz. Okay? That's related to speed of a processor, something like that. But in this case, it's related to frequency. Okay? The other unit that will cancel out meters per second and can be used for canceling out. Hertz doesn't cancel out anything because there's nothing in hertz in meters per second. But if you have seconds to minus 1, you can see how it might cancel out seconds. So speed here is meters per second. This is wavelength, is in meters, times 1 over second. So what you get is meters per second when you multiply those out. No, there's not any units that cancel out. So we're going to do this first problem. We're going to isolate frequency. So our units is going to be hertz or seconds to the minus 1. Whatever you want to put down is fine. So we'll put C equals wavelength times frequency. And then we need to take this equation and isolate frequency. So how do we do that? So we want to get V all by itself. What do we do? Take C divided by your wavelength. So it should be wavelength down here. I'm just showing you the cancellation of units or cancellation of symbols. So C, so V equals C over wavelength. I would like you to plug those numbers in and let's see what you get. Okay, let's see if you get the right answer. And remember, scientific notation, when you divide exponents, you subtract them. So, if you remember the rules we used, since we've got exponents of 8 and 4, negative 4, when we divide exponents, they subtract. So go ahead and calculate what you think the right answer is for that one. So that's what you would, that's what you'd end up with. So then you'd have to take your 3 divided by 7.3, and you get a number that's 0.41. I'm going to put it up here. 0.41 when you divide that out. And then that would be times 10 to the, then it would be 8 minus a minus 4, right? So it would be the 12th. So that's to the 12th. We move the decimal to the right one, which means we're going to change this and lower this exponent. Because we're making a smaller number bigger, which meaning adding a negative 1 exponent to that. So the answer should be 4.1 times 10 to the 11th. Is that what you guys have? Okay? Makes sense? So this is, I think what happens, we do a test. Students don't they get these two flipped around and they don't know which symbol represents which. But if you work with them enough, you'll know that the symbol V looks like a V, which is actually nu, is frequency, and upside down Y, which is lambda, is wavelength. You do that, you're going to be okay. If you show your units, that kind of will help you too. Alright, any questions with those type of problems? This will always be the same. It's a constant. It's 3 to the 8th. It never changes. All wavelengths have that value. Okay? Now, the second one we're going to do has to... the second one is very instrumental to what we do with energy of electrons in an atom, because each electron has a different energy in the atom relative to one another. And so we need to talk about this concept called energy. Energy is capital E. You've probably seen that before. The units for it is Joules, or shorthand J, and that represents joules. Now, there's this thing called Planck's constant. Okay, there was a scientist, chemist, that figured out this relationship of an electron and how much energy it has, and he made this correlation, and that's why the value is a negative 34th, because we're talking about one electron in an atom, and we're talking really, really, really small amount of energy with one electron, and so that's why the scientific notation is so small. So that's a constant like 3 to the 8th. So there's two ways in which you can approach solving for energy. One way is if you're given frequency, you can just multiply it by h. So if you got the frequency, these two are direct. So frequency and energy. Higher frequency, higher energy. Okay? Vice versa, lower frequency, which means a longer wavelength. Okay? So if this is lower, and this is lower. And they call that a direct relationship. Well, our line would be a linear line, is what we would have. Now, over here, it's not a direct relationship. It's inverted. Wavelength, the longer the wavelength, the bigger this number is here, all right? The bigger the y that you're dividing, the e is going to be smaller. So if this is bigger, you don't have to show this, I'm just showing it. This would be smaller. Bigger wavelengths has lower frequency, which means lower energy, and that's how they relate. Questions on that? Should be pretty easy if you look at your chart. It's going to show it that way when you compare the two. All right. So I've got a question for you. I want you to which two of these equations here would you use? Would you use the top one to solve? Because a lot of times it's picking out the right equation. Okay. So determine the energy of a photon. A photon we'll talk about later. It's just a bundle of energy given off by an atom that has a wavelength of 0.015 meters. So which of the two would we use? Top one or bottom one? Bottom, because it's wavelength. This is not frequency. So again, we have students on tests, they don't know the difference between them. One, they didn't do the assignments, so they didn't pay much attention to it, and then when it came time they had to differentiate between wavelength and frequency and energy and speed, that they kind of struggle with. I will give you the equations on the test, okay? So it's not like you don't know the equations, but I'm not going to tell you what H is, or I'll tell you H, the value of it, but I'm not going to tell you V is frequency and lambda is wavelength and C is speed of light, those type of things. So go ahead and set that up and see what you get. See what you get for an answer. So again, you would take C. I got them in the reverse order, but C times H divided by the wavelength. Then I simplified it, I multiplied it out. I got 19.9 times 10 to the minus 26, which would, scientific notation correctly written, would be 1.99 times 10 to the minus 25th. then divided by the wavelength. Minus 25 minus 2 is to the minus 23rd. So that would be your answer. Okay, so I'm going to go ahead and give you a sheet. You guys can practice these. None of these are real difficult. The issue I have, and students have, is they just are not very familiar with what the symbols stand for. And it's because maybe they're not paying attention to that when they're practicing in those type of things. So definitely want to make sure that you're doing that. So I'm going to go ahead and give it out.